In this video we are going to talk about covalent bonds as well as how to draw Lewis structures. Covalent bonds by definition are bonds formed due to the sharing of electrons between atoms. They are not transferring electrons, they are going to share them. So the key points with a covalent bond is this happens when the electronegativity difference between two atoms is low. So generally that means it happens from nonmetals bonding to other nonmetals. If you have a nonmetal bonding to a metal atom, the electronegativity difference is considered to be high and an ionic bond is going to form, which is not what we're talking about today. So covalent bonds are always when nonmetals bond to nonmetals. And there are single bonds, double bonds, and triple bonds with covalent bonds. A single bond by definition means sharing of two electrons. So if we were to draw a single bond, we could draw it like that. And that would be H2, our diatomic molecule. And that's actually what it looks like. It's sharing these two electrons. So both hydrogens have access to these two electrons as far as stability is concerned. For double bonds, they share 4 electrons. So to draw a molecule that has a double bond, we would draw oxygen, and oxygen has, each oxygen is sharing these 4 electrons. So this oxygen has access to it, as well as this oxygen has access to those 4 electrons. And by drawing them in the middle like this, says that they share them. Each oxygen actually has other electrons that they aren't sharing. These pairs of electrons are called unshared pairs, or lone pairs is the term that I typically use. So this oxygen atom, oh, I drew too many, excuse me. Let's get rid of those. This oxygen atom has 1, 2, 3, 4, 5, 6, 7, 8 electrons to make it stable, as well as this oxygen atom also has 8 electrons. It has 4 that it's not sharing, and 4 that it is sharing, and that is a double bond. Triple bonds share 6 electrons, and our primary example is nitrogen. And each nitrogen has access to these 6 electrons, as well as each nitrogen happens to have a lone pair. Once again, so each atom adds up to a total of 8 electrons, which happens to make it very stable. So up here I've shown you electron dot diagrams. Down here we can draw these more as structural formulas, where each pair of electrons is drawn as a straight line. This might look familiar to some of you, and it might not. So this is a single bond where it's sharing these 2 electrons. Oxygen has a double bond, so we would draw 2 lines. And we wouldn't ignore the lone pairs, because the lone pairs are really important for stability purposes. And then lastly, with that triple bond, we would draw 3 lines, remembering to draw in the lone pairs. So from now on, if you want to draw this or draw this, it really doesn't matter to me. They both get at the same thing. Alright, so there's 2 basic rules that we're going to follow when drawing Lewis structures. The first one I just like to call honk 1, 2, 3, 4, and this is a general guideline to how many bonds an atom will form, meaning hydrogen is going to form 1 bond, oxygen is going to form 2, nitrogen typically forms 3, and carbon typically forms 4 bonds, and as well as everything in column 17 forms 1, 16, 2, 15, 3, and column 14 forms 4 bonds. As you are drawing out a molecule, the atom that needs the most bonds to become stable goes in the middle. So for example, if we were to draw out methane, carbon typically forms 4 bonds, hydrogen typically forms 1. Carbon needs more bonds to become stable, so we're going to put carbon in the middle and surround it by hydrogens. And we are going to draw straight lines to indicate that each carbon with one carbon with each hydrogen is sharing 2 electrons. The second rule that you follow is called the octet rule, except for hydrogen. All atoms require a total of 8 shared as well as unshared electrons to be stable. These unshared electrons are our lone pairs that I had talked about on the previous slide. Hydrogen only requires 2 as well as helium, but helium doesn't bond with anything else. You can call it the duet rule if you want to. It doesn't matter to me. Just remember that hydrogen will only ever form one bond, and it never ever has lone pairs. This makes hydrogen stable, just that one bond. So 8 electrons happens to fill the highest energy S and P orbitals, going back to electron configurations, which is believed that's why atoms become stable, is due to those highest energy orbitals being filled. So we're going to follow these 2 rules in order. You're going to do this rule first and then fill in lone pairs with your octet rule. For purposes of this class, like the slide says, that's going to lead you to a correct answer. We're simplifying things a little bit, but we aren't going to get into any exceptions where these 2 rules aren't going to get you down to a right answer. If you go on and take another chemistry class, you will see that there are definitely some exceptions as we get to bigger atoms. Alright, so the honk 1, 2, 3, 4 rule, what that means is if we bring a hydrogen over here, everything in column 17 is going to form 1 bond. Everything in column 16, where oxygen is, will form 2. Column 15 is going to form 3, and column 14 is going to form 4. So we're essentially going to write honk backwards. And it gives you a good idea of how many bonds these atoms need to be stable. What about the rest of these guys? Well, we're talking about covalent bonds, and covalent bonds are nonmetals to nonmetals. And you, looking at the whole periodic table, will find that columns 14 through 17 pretty much are our nonmetals. So we aren't concerned with the rest of the periodic table. Alright, a few examples. We're going to follow the honk rule first, and then the octet rule. And these 3 examples should give you a good idea of the decision-making process as we're going through to draw Lewis diagrams. So nitrogen requires 3 bonds typically to become stable. There's only 2 of them, so they both or neither are the central atom depending on your perspective. However, they can only bond with each other, so we are going to go ahead and make a triple bond. And now we've obeyed our honk 1, 2, 3, 4 rule. Nitrogen has formed 3 bonds. Now we need to look at the octet rule. The octet rule is where you're going to fill in lone pairs to make sure that each individual atom has 8 electrons between the shared and the unshared, or the lone pairs. So right now we have 2, 4, 6 electrons going to both nitrogens. So we need to add a lone pair here, which gives this nitrogen 8 electrons, as well as we need to add another lone pair over here, which gives that nitrogen 8 electrons. For Si2H6, if you look, silicon is in the same column as carbon on your periodic table, so it's going to obey the C in our honk 1, 2, 3, 4 rule. It needs to form 4 bonds to become stable, versus hydrogen only needs 1. So in this instance, we're going to have 2 central atoms. They're both going to be silicon. And for right now, we are going to just put them together with a single bond because we have 6 other hydrogens we have to fill in. Most molecules are symmetrical. So there's 6 total. So first off, give 3 to this one and 3 to that one and see where you end up. Hydrogen only forms 1 bond, so that's all we are going to draw. Silicon wants to form 4 to become stable. So we've drawn in our 6 hydrogens. Let's count. We have 1, 2, 3, 4 bonds for this silicon. For this one we have 1, 2, 3, 4. So we've obeyed that rule. Next we have to check the octet rule. They all need 8 except for hydrogen, which only gets the 1 bond. Then you're done. So silicon has 2, 4, 6, 8 electrons, and this one also has 8. So you are done. You've checked both rules. Lastly, PCl3. Phosphorus is in the same column as chlorine, I believe. Let's check. Turns out it's in the same column as nitrogen, so it's good that I checked. Phosphorus, being in the same column as nitrogen, needs 3 bonds to become stable. Chlorine is in the same column as fluorine, which is where we placed our H over column 17. So anything in column 17 only needs 1 bond to become stable. So we're going to put P in the middle and surround it by the chlorines. Well, that's annoying. Sorry. P goes in the middle. We're going to surround it by chlorines. Phosphorus has formed its 3 bonds, obeying the honk rule. Chlorine, each one of them has formed 1, obeying that rule. Now for the octet rule, they each need 8. Phosphorus right now has 2, 4, 6, so we're going to give it 1 lone pair. Each chlorine only has 2. So we need to give it 3 sets of lone pairs for a total of 6 electrons that are not being shared. If you do forget to draw in the lone pairs, technically the molecule is incorrect because you aren't showing it as being stable. And I have to say that is very common, is that students will forget to draw in the lone pairs. They'll just draw in the straight lines to indicate where the bonds occur and forget to draw in those. So please remember to check both and draw in your lone pairs.